Welcome DIKWP, 小工 aboard. Your learning journey starts now. Ever wondered if AI could start thinking for itself? Scary, right? But what if we had a map, a super smart framework to guide its thoughts? That's where DIKWP comes in, a clever way to keep AI's mind on track. So, what is this DIKWP magic? Think of it as a five-layered cake, but instead of layers, it's layers of meaning. We've got data, the raw ingredients, like sensor readings. Then, information, connecting the dots, like fever plus low blood pressure. Next, knowledge, applying rules, like infection shock. Then wisdom, making smart calls, like a doctor's plan. And finally, purpose, the big why, the ultimate goal. The cool part, it's not just a pyramid, it's a web. Each layer can talk to any other layer, creating 25 possible paths for meaning to flow. This network structure allows for constant feedback and updates, making the AI's thinking process dynamic and self-correcting. It's like having a built-in GPS for AI consciousness. Now, let's zoom in on the star of the show, purpose, or P. This isn't just some vague goal, it's a computable target. We can define it mathematically, often using a function f sub p that takes everything from data up to wisdom and churns out the intent. How does it get there? Two main routes. You can go bottom up, starting with raw data, layer by layer, until you reach the final intent. Or, sometimes, you jump top down. Maybe you have a hunch at the wisdom level, and you use that to figure out what knowledge you need, what data you need, and directly shape the intent. It's like having cheat codes for problem solving. And because of those feedback loops we talked about, the system constantly checks if things are aligned with the overall purpose. If not, it adjusts. It's all about staying on mission. Okay, so the system is smart, but what if it gets stuck? Or encounters something weird? Enter the consciousness bug theory. Sounds dramatic, right? Think of bugs not as errors, but as necessary leaps in reasoning when the normal path hits a wall. For instance, bug 1. Imagine critical data is missing, and time is critical. Instead of freezing, the system might bypass the usual steps and jump from its current wisdom W straight to a provisional intent P prime. It's like saying, okay, data's bad, but based on my experience, I'll try this. Formally, if the data D is seriously incomplete, then W leads to P prime. Another one, bug 2. What if the information layer I throws up contradictions? Like two test results that can't both be true? Instead of crashing, the system introduces a new piece of knowledge Ki to resolve the conflict, making the knowledge base K more robust. It's like adding a footnote. Wait, maybe this is an exception? These bugs aren't flaws. They're controlled, rule-based ways to handle uncertainty and keep the system moving towards its goal, even when the path gets bumpy. Let's make this real. Picture an AI medical assistant. Patient comes in, coughing, feverish, low blood pressure. Some tests done, some missing. Step 1. Data D, symptoms, vitals, partial labs. Step 2. Info I, high fever, low BP, high white cells. Step 3. Knowledge K, infection, maybe pneumonia, maybe sepsis, but wait, key info is missing. Step 4. Wisdom W kicks in. It sees the uncertainty and says, not enough, need that lung scan. This is crucial feedback. It doesn't guess blindly. It requests the missing data. Once the CT scan D arrives, the cycle repeats. Updated info, I refined knowledge K, and now Wisdom W can confidently generate a solid treatment plan, W plan. Finally, Intent P delivers the recommendation. See? No wild guesses, just a structured feedback-driven process ensuring safety and accuracy. That's DIKWP in action.